When people ask how vast the universe is, they usually expect a number, a diameter, a distance, something measurable. But the honest answer is more complicated, because the universe doesn't just have size, it has layers of scale. And every time we think we understand the scale, we zoom out and realize we were only seeing a fraction of the picture. So instead of starting with numbers, let's start with something simple. You are standing on Earth. Earth feels big. It has oceans, continents, weather systems, mountains that stretch for thousands of kilometers. But in cosmic terms, Earth is barely a rounding error. Today we are going to zoom out, slowly and carefully, from Earth to the largest structures we know exist. And by the end, you may feel small. You may feel something more interesting. Perspective. Earth's diameter is roughly 12,742 kilometers. You can drive across a continent in days. Fly across the planet in less than 24 hours. Now compare that to the Sun. The Sun's diameter is about 1.39 million kilometers. You could fit roughly 1.3 million Earths inside it by volume. That sounds extreme, but the Sun is not an extreme star. It's classified as a G-type main sequence star. Fairly typical. There are stars like Betelgeuse and UY Scuti that are hundreds of times larger in radius. If one of those replaced our Sun, its surface could extend beyond the orbit of Mars, possibly even Jupiter. Already, our sense of scale begins to wobble. But we're still in our own solar system. The distance from Earth to the Sun is about 150 million kilometers, 1 astronomical unit. Light takes about 8 minutes to travel that distance. That feels fast. But Neptune, the outermost major planet, orbits about 30 astronomical units from the Sun, or the equivalent of approximately 4.5 billion kilometers. Light takes roughly 4 hours to reach Neptune. And beyond Neptune lies the Kuiper Belt, a region filled with icy bodies. Even farther out, we suspect the existence of the Oort cloud, a spherical shell of icy debris that may extend up to 100,000 astronomical units away. If that's accurate, the Oort cloud would stretch nearly halfway to the nearest star. To visualize this properly, if the Sun were the size of a marble, Earth would be a grain of sand about a meter away. Neptune would be far across a large room. And the nearest star system, Alpha Centauri, would be thousands of kilometers away on that same scale. The solar system isn't crowded. It's mostly empty. Alpha Centauri is about 4.37 light-years away. A light-year is not a measure of time, it's distance. About 9.46 trillion kilometers. That means the light we see from Alpha Centauri tonight left that star system more than 4 years ago. Now consider this. Our fastest spacecraft, Voyager 1, has been traveling since 1977. It has only just entered interstellar space. At its current speed, it would take tens of thousands of years to reach Alpha Centauri. And that's the closest star system. Our galaxy contains somewhere between 100 and 400 billion stars. The Milky Way's diameter is roughly 100,000 light-years. If you could travel at the speed of light, which we cannot, it would still take 100,000 years to cross it. And this is just one galaxy. In the early 20th century, astronomers debated whether the Milky Way was the entire universe. Then Edwin Hubble observed Cepheid variable stars in what we now call the Andromeda Galaxy. That discovery proved Andromeda was far outside our galaxy. It changed everything. Today, based on deep field observations from telescopes like Hubble and James Webb, astronomers estimate that the observable universe may contain hundreds of billions of galaxies, possibly more. Earlier estimates suggested around 100 to 200 billion, but newer modeling indicates the number could be significantly higher, especially when accounting for faint dwarf galaxies. Each galaxy contains millions to trillions of stars. Many of those stars likely host planets. The scale increases not linearly, but exponentially. Galaxies are not randomly scattered. They form groups. The Milky Way is part of the local group, which includes Andromeda and about 50 smaller galaxies. The local group is part of a larger structure known as the Virgo supercluster and is about 110 million light-years in diameter. And beyond that lies Laniakea, a vast supercluster structure spanning roughly 520 million light-years and contains about 100,000 galaxies. On even larger scales, galaxies form a cosmic web, enormous filaments of matter separated by vast voids. These filaments can stretch hundreds of millions of light-years. The observable universe is not chaotic. It has structure, but the structures operate on scales far beyond human experience. Based on the standard lambda-CDM cosmological model, the universe is about 13.8 billion years old. So why is the observable universe about 93 billion light-years in diameter? The answer is because space itself is expanding. Light from distant galaxies has been traveling toward us for billions of years. But during that time, space between us has expanded. So those galaxies are now much farther away than the simple age of the universe would suggest. The observable universe has a radius of about 46 billion light-years, which means its diameter reaches approximately 93 billion light-years. But this is not the edge of everything. It's simply the edge of what light has had time to reach us since the Big Bang. Beyond that, there may be more universe, possibly much more. Current measurements suggest the universe is very close to geometrically flat. In cosmology, a flat universe could imply it is infinite in extent, though we cannot confirm that definitively. It could also be finite, but so large that its curvature is undetectable from our perspective. Either way, the observable universe may be just a small region of a much larger whole. And there are parts of the universe receding from us faster than the speed of light. Not because they're moving through space that fast, but because space itself is expanding. Light from those regions will never reach us. They are permanently beyond our horizon. There may be around 10 to the power of 22 to 10 to the power of 24 stars in the observable universe. That's a number with 22 to 24 zeros. Comparisons like more stars than grains of sand on Earth are not poetic exaggerations. They are attempts to translate incomprehensible quantities into something tangible. But even that comparison falls short. Human cognition is not built for astronomical magnitudes. We evolved to judge distance across valleys, not across billions of light years. The universe isn't just vast. It's getting vaster. Expansion is accelerating due to dark energy. In tens of billions of years, distant galaxies will drift beyond visibility. Future observers in our galaxy may see only the Milky Way and Andromeda merged together. No evidence of the broader universe. We happen to live in an era when the cosmic background radiation is still detectable and distant galaxies are still observable. Cosmologically speaking, we arrived at a fortunate time. So how vast is the universe? At minimum, the observable portion spans 93 billion light-years. It contains hundreds of billions, perhaps trillions, of galaxies. It may extend far beyond what we can see, possibly infinitely. But the most extraordinary part is not the scale. It's that in a universe this large, matter organized itself into stars. Stars formed planets. On at least one planet, chemistry became biology. And biology became conscious enough to measure the cosmos. The universe is vast beyond intuition. But within that vastness, there is awareness. And that may be the rarest phenomenon of all.